Okay, I am going to go over this Unit 5 review with you. The first few problems I already have worked out, and I'm just going to kind of run through them because I feel like they're easier. And then I have a whole bunch in here that I'm actually going to work out from the first step to the last step, just in case you're struggling with those kind of problems. Okay, this first problem, we want to add these together, these radicals, but right now I can't do that because I don't have the same number underneath the radical. Remember, in order to add radicals, you need to have the same number underneath the radical. So like if I wanted to add this together, I can add this together because they both have a square root of 3. So when you do that, you just add the outside coefficients, 2 plus 4 is 6, and then the square root of 3 just tags behind. Okay, but number 1, I don't have the same number underneath, so I can't do it right now, but I can simplify. So this is when I want to find my largest perfect square that goes into 18 and how many times. My largest perfect square that goes into 32 and how many times. So I found that 9 is the largest perfect square that goes into 18 twice, 16 is the largest perfect square that goes into 32 twice, and then I break it down from there. The square root of 9 is 3, square root of 16 is 4. I can multiply the 7 and 4 together to make 28. And now that they both have square root of 2 in the back, I just add my outside coefficients. So my 3 and my 28 makes 21, and then the square root of 2 just tags behind. 31, I'm sorry. Okay, number 2, I just want to simplify the square root of 845. So I want to find my largest perfect square that goes in there and how many times. And it is 169, goes in there 5 times. The square root of 169 is 13. You can't take the square root of 5, so that just stays. That was a big one. All right, this next one. I'm multiplying because the parentheses are smushed together. So first I multiply my outside numbers, my 2 and my 3, which makes 6. And then I multiply the 15 and 10, which makes square root of 150. Once I have that, I need to break down the square root of 150. So what's the largest perfect square that goes in there? How many times? And it's 25 goes in there 6 times. The square root of 25 is 5. You can't take the square root of 6. And then that 6 drops down. Multiply the 6 and 5 together, and that gives you 30 square root of 6. Okay, number 4. I'm looking at square root of 9 over 25. Remember, I can write this in pieces. So I rewrote it as square root of 9 over square root of 25. These are both perfect squares. So the square root of 9 is 3, square root of 25 is 5. So the answer is simply 3/5. Okay, number 5. This was one where I had to rationalize the denominator. For my students, I call this the FFU, our fancy form of 1. So I then can multiply straight across. I get the square root of 54 over 2, and then I have to break down the square root of 54. What's the largest perfect square that goes in? How many times? And then I can take the square root of 9 and get 3, and then I just recopy everything else, and that's all you can do there. Okay, these next 3 problems, these should be really easy for you. I'm trying to figure out what kind of a triangle they are. And so this is where I work out my a squared plus b squared and my c squared. And so that's what I did. Remember, c is always the longest side, so 10's the c. So I compare a squared plus b squared to my c squared, and I get that they equal. So that's a right triangle. My next one, my c is the 7, because that's the longest side. So I compare the a squared plus b squared to the c squared. And when I work that out, I get that my c squared is smaller than the a squared plus b squared. So if c squared is the smallest, then that's when it's a cube. And then number 8, this one was a little trickier. 10 is the longest side, so that's the c. So I compare 5 squared plus 5 square root of 3 squared to the 10 squared. And I just want to show you this one. 5 square root of 3 squared means 5 square root of 3 times 5 square root of 3. And then I can multiply those outside numbers. 5 times 5 is 25. And then I can multiply square root of 3 times square root of 3, which is just a 3. And if I multiply 25 and 3 together, I get 75. So if I compare, I end up with 25 plus 75, which is 100. 10 squared is 100, and once again they equal. So this is a right triangle. Okay, and if you look at these numbers, it actually follows the pattern to the 30, 60, 90 triangles, where one side is x, one side is x squared root of 3, and the other side is 2x. Okay, now, these others, I pretty much am going to work out as we go along. So if you already have these problems done, then you can always fast forward through me so you can see the answer, but if you feel like you need an explanation, then that's what I'm about to do. So we want to figure out if we're going to use Pythagorean theorem, if we're going to use special right triangles, the 30, 60, 90, and 45, 45, 90, or if we're going to use our trig to calculate the answers. So let's look at number 9. Number 9, I can see very clearly that this is a 30, 60, 90 triangle. So I'm going to use those special formulas. So I'm going to start by labeling my sides. Across from the 30, I label with x. Across from the 60, I label with x squared root of 3. And across from the 90, I label with 2x. Okay, I always need to know what x is, and I do. X is 7. So this is the easy one. If x is 7, I just plug 7 in everywhere I see an x. So if I put a 7 where this x is, 2 times 7 makes this side 14. If I put a 7 where that x is, then this side is 7 square root of 3. So x, this side, is 7 square root of 3. And y, this side, we found to be 14. Okay, looking at number 10. This is not a 30, 60, 90. It's not a 45, 45, 90. I don't know 2 of the sides, so I can't use Pythagorean theorem, so it's trig time. Okay, I'm going to start labeling. I always like to label the hypotenuse first. So across from the right angle, that's always the hypotenuse. The angle in question is this 47-degree angle. So if I want to talk about what x is in regards to the 47, it's right next to it, so that's adjacent. So what do we use when we're talking about adjacent and hypotenuse? Cosine. Remember SOHCAHTOA? So I take the cosine of the angle. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse. My goal is to solve for x here. So to get rid of the division of 13, I multiply both sides by 13. The 13's cross out, and all I have to do is put this right here in my calculator, and I'll have the answer for x. So first of all, let me go to my mode and just make sure that I am in degrees, which I am not. So I go over to degrees. I'm going to quit that screen, and then I'm going to put in 13 times the cosine of 47. And if I round to the nearest tenths, that would make 8.9. Okay, number 11. I can do Pythagorean theorem with this. It's a right triangle. I know 2 of my sides, so I could go 7 squared plus 7 squared is x squared. Or, since I know these 2 sides are equal, these 2 angles must be equal. So these would both be 45 degrees. So this here is a 45, 45, 90 triangle. So I'm just going to do it that way. Across from the 45, we label with x. And across from the 90, we label with x squared root of 2. And do I know what my x is? I sure do. X is 7, so I'm going to put a 7 where that x is. And this side is 7 square root of 2, which is what they wanted to know. I also could have done this with Pythagorean theorem, like I said, where I would set up 7 squared plus 7 squared is x squared and work it out that way, but it actually takes longer. Okay, number 12. This is a 45, 45, 90 triangle as well. So let me do my labels. Across from the 45, I label with x. And across from the 90, I label with x squared root of 2. Do I know how long my x sides are? Nope. So I need to solve this equation right here for x. So to undo multiplication, I'm going to divide. So I divide both sides by the square root of 2. This is my answer right here for x. We're just not allowed to leave square roots in the denominator, so I need to rationalize my denominator. I need to multiply by my FFU, my fancy form of 1, and that makes 24 square root of 2 over 2. And then I can reduce my 24 over 2 to give me 12 square root of 2. And that's how much x is. So that's what both of these sides are. This side is 12 square root of 2, and this side is 12 square root of 2. And that's what we wanted to know, is what is x and what is y. So 12 square root of 2, 12 square root of 2. Hopefully these 45, 45, 90s and 30, 60, 90s, hopefully they're getting a lot easier for you. Okay. Let's move on to number 13. I'm going to go ahead and blow this up just a little bit in case you guys have been squinting. Hopefully that has not been the case. Okay, looking at number 10. Or sorry, number 13. Let's get it unfuzzy. Okay, this is definitely a trig problem here because I'm looking for an angle, so I know I have to use trig. First of all, I look to see if I'm given the hypotenuse. I'm not. So let me go to the angle. The 10 is all the way across from it, so the 10 is the opposite side. 7 is right next to it, so the 7 is the adjacent side. So what do we use when we're working with opposite and adjacent? Tangent. So it's the tangent of the angle, which is x. Tangent is opposite over adjacent, so opposite over adjacent. If I want to get x by itself, I have to remove the tangent, so this is when we do the inverse. So x would be the inverse of tangent of my 10 over 7. Okay, all I have to do is put that in the calculator. So to do inverse tangent, I'm going to go second tangent. And after I do second tangent, I'm going to put in 10 divided by 7. And if I round to the nearest tenths, that's just 55. Okay, looking at 14. I'm going to use trig here as well. It's not a 30, 60, 90. It's not a 45, 45, 90. I don't know two of the sides of the right triangle. So let's see if I was given the hypotenuse. I sure was. Across from the right angle is the hypotenuse. If I go to the angle in question, x is the side all the way across from it, so that's opposite. What do we use with opposite and hypotenuse? Sine. So it's sine of whatever the angle is. Sine is opposite over hypotenuse, so x over 24. My goal is to get x by itself, so to get rid of division of 24, I multiply both sides by 24. And then all I have to do is put 24 times sine of 36 in my calculator. So let me do that. So 24 times the sine of 36. And if I round that to the nearest tenths, that will make 14.1. Okay, number 15. We want to know the length of RS. Well, I see I have myself a 30, 60, 90 triangle. So, across from the 30, I label with x. Across from the 60, x square root of 3. And across from the 90, 2x. So I need to know what my x side is. I do not. So I need to solve this equation here. I'm going to come over here and solve it. I undo my multiplication by dividing. So I divide both sides by the square root of 3. I can't leave it like that, so I'm going to rationalize the denominator. I'm going to FFU, fancy form of 1. When I go straight across, that makes 12 square root of 3 over 3. And then I can reduce that to 4 square root of 3. And that's what x is. So let's look. They want the length of side RS, which is the x, and I just found x to be 4 square root of 3, so that's my answer. I don't even have to mess with finding this side. Okay, number 16, tangent of theta, and this says simplified fractions. So this just wants the ratio. So remember, tangent is opposite over adjacent. So let's come over to the angle. And if we look, the 13 is the hypotenuse. The 5 is right next to the angle, so that is the adjacent. Let me go ahead and make that a capital H in red so you can see it. Now, because I'm doing tangent, I need opposite over adjacent, so I actually need to figure out what that side of the triangle is. So I need to do a little work here. I can do Pythagorean theorem because it's a right triangle, so I want to figure out what this side is right here. Let me just call it x. So it would be x squared plus 5 squared equals 13 squared. So x squared plus 5 squared equals 13 squared. Does this look like anything you might know about? Let's see. So if I subtract 5 squared from both sides, 13 squared minus 5 squared makes 144. And if I square root both sides, that makes 12. This is our 5, 12, 13 triangle. So if you recognize that it was a 5, 12, 13 triangle, one of our Pythagorean triples, then you wouldn't had to have done all this work over here. You could have just known that that side was 12. But if you didn't know that, you can always use Pythagorean theorem. Okay, so the side all the way across from the angle, that's the opposite. So now I can do this. If tangent is opposite over adjacent, then it's opposite 12 over adjacent 5. And there's my answer. So tangent of theta is 12 over 5. Okay, number 17. This is another trig problem. So let's see. I have the hypotenuse, that's across from the right angle. Let me go to the 51-degree angle. 14's all the way across from it, so that's opposite. So what are we going to use here? Sine. So it's sine of the angle equals opposite over hypotenuse. So 14 over x. In this problem, I need to get rid of my division of x, so I'm going to multiply both sides by x. When I do that, I'm left with x times sine of 51 equaling 14. I still don't have x by itself, so I have to get rid of my multiplication here by dividing. So I'm going to divide both sides by the sine of 51. And just for safe measure, I'm going to go ahead and put this in parentheses when I plug it in my calculator. So I'm going to put in 14 divided by, parenthesis, sine of 51. Let's see if I actually needed those parentheses. 14 divided by sine of 51. And I didn't. But just to be safe, sometimes it's good to know. All right, and that makes 18.0 if I round to the nearest tenths. So I'll go ahead and I'll put the 0.0. I should pop back up and do that on number 13. Go ahead and put the 55.0 also. Since technically we're rounding to the nearest tenths, I should have something in the tenths place. Okay, let's go over to number 18. Number 18, this looks like Pythagorean theorem. So x is my c, so it's going to be 40 squared plus 9 squared equals x squared. If I work out 40 squared plus 9 squared, that makes 1681. I'm just going to see if that happens to be a perfect square. So if I take the square root of 1681, sure enough, it's a 41. So x is 41. This happens to be a Pythagorean triple, but you might not have recognized it. Okay, number 19, it looks like we're dealing with a 30, 60, 90. So let me label. Across from my 30 is going to be my x. Across from my 60 is x square root of 3. And across from my 90 is 2x. So let's see if I know what x is. I don't. So I need to solve this equation here for x. So to undo multiplication, I divide. So I divide both sides by square root of 3. This one's super nice. Those square roots of 3 cancel out. Those square roots of 3 cancel out. All I'm left with is x is 8. So now I'm going to plug in an 8 everywhere I see an x. So this side right here would be 8. This side right here would be 2 times 8, which would be 16. So side x, this is side x. We found it to be 16. Side y, this is side y, and we found it to be 8. And we're done with that one. Really nice. Okay, number 20. It looks like I have a few things to do. So right off the bat, I notice that I'm going to need to work with this triangle here on the left. I realize that this is a 45, 45, 90 triangle because those two sides are congruent. So it's 6, 6, 6 square root of 2. If you need to go through your labeling process to know that, you can. That one was pretty easy, so I didn't even bother. Okay, and now when I focus in on this triangle, I don't know what these angles are, so I'm just going to use Pythagorean theorem here. So which one of these is my C? The 16. So it's x squared plus 6 square root of 2 squared equals 16 squared. Okay, let me figure out what 6 square root of 2 squared is. I'm going to do it off to the side. Of course, you could always use your calculator. 6 square root of 2 squared means 6 square root of 2 times 6 square root of 2. 6 times 6 is 36. Square root of 2 times square root of 2 is just a 2. And if I multiply those together, I get 72. So I'm going to subtract 72 from both sides. And if I do that, let's see what I get. So in my calculator, I'm going to take 16 squared minus 72. And when I do that, I get 184. And then when I square root both sides, I know that this is not a perfect square, so it's not going to come out nice. So I want to try to break it down. I want to try to find the largest perfect square that goes in there and how many times. And so I can see that 4 goes in there 46 times. The square root of 4 is 2. I can't take the square root of 46, so I just leave that. And that's my answer. 2 square root of 46. Okay, 21. Here I am. I'm looking for sine, cosine, and tangent. So we're all talking about angle A. So let me come over to angle A and start labeling. Across from the right angle is always the hypotenuse. Right next to it is adjacent. And all the way across from the angle is opposite. Okay, so sine is opposite over hypotenuse. So opposite is 4 over hypotenuse, 4 square root of 5. I actually can reduce this. Sorry, this is so messy. Those 4's can cancel out. And so let me just come down here. If those 4's cancel out, I'm left with a 1 on top and a square root of 5 on bottom. I can't leave it like that, so I have to rationalize the denominator. Foo-foo! And if I do that, I get square root of 5 over 5. And that's my answer to sine of A. Okay, cosine is adjacent over hypotenuse. So adjacent is 8. The hypotenuse is 4 square root of 5. I can reduce 8 over 4 into 2. So that leaves 2 over square root of 5. I need to rationalize the denominator. So if I multiply by square root of 5 over square root of 5, what would that give me for a final answer? 2 square root of 5 over 5. Hopefully you can start to do that in your heads. Okay, and then tangent is opposite over adjacent. So opposite is 4, adjacent is 8, and I can reduce 4 over 8 into 1/2. And so that's the answer for tangent of A. Okay, I'm going to stop there, and I'm going to put the rest of the problems on a different video because this is getting pretty long. Thank you so much.